Hi, I'm Maren Leed, the Executive Director of the National Spectrum Consortium, and I'm here today for one of our spotlight talks with our members. One of the things that we do to try to highlight their capabilities in a little bit more depth and hopefully enable greater collaboration and awareness across the consortium. So I'm thrilled to be here today with Sriram Vishwanath, the CEO and co-founder of GenXComm. Sriram, great to have you.
Glad to be here. Thank you for having me. I'm excited to be on this forum. Thank you for the invitation.
So could you just start by saying a little bit about you and your role and the basics about GenXComm?
For sure. So again, as a co-founder of the company, I've been working on this piece of technology for, oh boy, 8-9 years now, well, almost a decade. And I started off working on this as a professor at the University of Texas. I was lucky enough to meet a lot of the brilliant and smart graduates, undergraduates, staff members at the university. And that's how the whole thing happened. We got together, so the credit goes to all the brilliant people at the University of Texas for making this possible. And then GenXComm came to being. Our core technology is to leverage intelligence from a signal processing, from a communications, from a networking perspective to build scalable 5G solutions in the US. So we are heavily focused on enabling 5G through innovative technologies in the US. And so all of this took a lot of deep, intense research from a bunch of brilliant people who I'm very happy to be associated with. We've been a company for 5 years. And in that 5 years, we have accomplished a tremendous amount, from just the idea coming to life at the university to becoming an actual working, amazingly robust and reliable product. So I'm excited that this journey has been both an intense and an amazing journey, both at the same time.
It's like quite an adventure.
Yeah.
So you've been able to bring some of the things that you've been working on to some of the 5G work that the consortium's doing. Can you talk a little bit about what your role is and exactly what that participation has looked like?
Yes, in fact, I first of all want to thank the consortium. The consortium has been, in fact, a beacon in many ways for 5G, for communications in the US, and beacon worldwide, but especially in the US where we need it so badly. What we've been doing with the consortium is working on what we call 5G meshing. So this concept of meshing, I want to talk a little bit more about it. The concept of meshing is the notion that multiple radios can all talk to each other while also talking to your phones and your laptops and all your devices. So it talks to everything that you use, phone, laptop, PDA, whatever you're using, and they can talk to each other, which is pretty, not just innovative, pretty revolutionary in its thinking. That mesh network, there's various aspects to it, relaying, working on not just talking to each other, but talking to the tower, having multiple reliable paths to get the data out. We enable that, and we've been doing that in concert, through sponsorship, through support from the National Spectrum Consortium. And it's not just been a great experience until now, meaning, and it'll be a great experience, I'm sure, in the future too, but it's been an opportunity for us to showcase what this meshing technology can do, both for dual use, so both for potentially applications within the DoD and federal, as well as commercial.
So can you talk also a little bit about how you manage that mesh network and limit interference? Because I know that's
Yes,
huge
it's a big deal.
complication. So can you say a little bit more about your approach to that?
Yes, I'd love to. So one of the biggest problems we have in communications is interference. So think of it as almost like you and I are talking. When we talk, if the two of us are talking, we talk one after the other. Imagine now we had 100 people in the room all talking. Interference becomes a huge problem. And that is a problem not just for people talking, it's also a problem for communication systems worldwide, which is when there's a bunch of devices all talking, all in the same spectrum, they interfere with each other. What's even worse is we self-interfere, which is when I'm talking, I can't hear anybody else. It's, me talk, and everybody else has to listen. If they start talking, I have to shut up, right? So that's the issue, is we not just interfere with each other, we interfere with ourselves too. Now, radios are the same. They interfere with everybody else and they interfere with themselves. We solve this problem by enabling that self-interference to disappear. So essentially what that means is when a radio is talking to other radios, it can hear everybody else, which is almost incredible to say. But what I'm telling you is it can listen and talk at the same time in the same frequency without interference. Now, this makes a huge difference because if you can listen and talk at the same time, you can mesh much better. Now, what is meshing? As I mentioned, meshing is that different radios that talk to each other. If while they're talking, they can hear other mesh radios, it makes the process of coordinating transmissions, it makes the process of ensuring they don't step on each other much, much, much cleaner. So one analogy I give people is today's radios are like a bunch of people with, blinds on their eyes, right? They've been blindfolded and they've been asked to get out of the room without bumping into each other. So what ends up happening today, imagine you put 50 people in a small room and they say, get out of this room without bumping into each other. So what you do is you feel your way around. If you bump into somebody, you say, oh, excuse me, you back off and somehow find your way out of the room. It's a difficult process. Imagine being blindfolded, put in a room and being asked to find your way out. What our technology enables is for that blindfold to be removed. So essentially, every radio can see every other radio. Every 5G node, mesh node, can see every other 5G mesh node for the first time. And the reason they can see it is because when they're talking, they can see everybody else. Today's radios, when they're talking, are blind to everybody else. That's the difference. Because they can see each other, they can find a neat, coordinated way to get out of the room. That makes such a huge difference. So I'm talking about some cases, orders of magnitude difference in latency, in throughput, and overall network performance. So this, for multiple reasons, from an innovation perspective, which is technology, from a product perspective, and ultimately from a deployment perspective, leads to a much better network.
So as you're starting to deploy your technology and build out some of these networks and in some of the pilot-based work that the Defense Department's doing, are there things that you are learning that were unexpected? Are you appreciating new frontiers as we move through the learning process? What hypotheses are holding out, and then what new ones are you uncovering?
Great question. So yes, we're learning a lot. So one of the things that we're learning is that there is a lot more intelligence that can be built into the network itself if the network can eliminate interference. Another way of putting it is, if you're blind, you can surmise what's going on. If you can see, now you can gather intelligence with that. Does that make sense? So if you can continuously see your environment, you can be intelligent about what's going on in it all the time. That intelligence is critical. So if I can not just, another way of putting it is, if there are rogue players, I can watch them even while I'm transmitting. If there are anomalous or unusual characteristics, I can capture them right at the radio level. I can do things and I can build in smarts into the radios that just was not conceivable before. And that we are learning with time is a very powerful tool for all of us. It's called signal intelligence. It's called edge intelligence. And this edge intelligence is a very big deal. And the reason it's a big deal is that today we tend to be more reactive than proactive. When something bad happens, we go, oh, something bad has happened. Let's try to fix it. It is smarter to be proactive, which is to say, hey, it's likely something is going to happen because of what I'm sensing. I don't know if that makes sense.
Yeah.
And so if the more I can be intelligent about it, the more proactive I can be, the better the overall network, not just in terms of resilience, not just in terms of performance, but also in terms of security and in terms of privacy, which matters a lot in many cases. So depending on what your end goal is, building in not just interference cancellation, but that edge intelligence to go with it can build an overall better solution.
Well, so you started out by talking about the team that you had the opportunity to work with and to build your company with. That resonated with me because our focus so much at the consortium is on collaboration and on hopefully enabling interactions among really sort of cutting edge companies like yours who have pieces of solutions that are the sum of which is greater than the individual parts, right? And so I wanted to just ask you a little bit about the collaborations that you've been able to form both as part of the consortium and then ones that may have been informed by the consortium, but maybe manifesting themselves outside of that. Just what's that environment look like for you? And could you say something about some of your partners?
I appreciate that. And I think you've highlighted something that I want to make sure I emphasize, which is there's, of course, the resources aspects of being part of the consortium, but there is the teaming and the collaboration and the exchange of ideas that happens within the NSC that is just, if not more, invaluable. Because yes, working on very interesting projects together through the NSC is important, but you get exposed to concepts and collaboration opportunities that go even beyond those opportunities into much broader set of opportunities, both commercially and otherwise. So I want to A, thank the consortium for making this possible, but B, I want to make sure I highlight that there's many companies who are at different stages, early, mid, fairly advanced, all of whom are benefiting from this exchange of ideas that happens, there's opportunities to collaborate that happen through the NSC. Now, in our particular case, we've had a few different collaboration opportunities. I'm not sure I'm at liberty to given NDAs, I'm not sure if I'm allowed to disclose the details of them, but the short answer is yes, we have benefited quite a bit from those exchange of ideas. We are looking at multiple different opportunities just coming out of the fact that we, in discussion on collaboration. So not just the projects itself, but beyond that. So all of those have had a very positive impact on us. But I don't know if I'm allowed to share any details. So I'll leave it at that.
All right. Thank you for that. Let me just take one final question, if I could.
And very quickly, if I'm allowed to share details, I'll check and I'll come back. And anyway, all right. Please go ahead.
So just, I thought it'd be fun to close with what are the big technical things, the next challenges that you want to tackle that you think are important to continuing to advance this 5G ecosystem that we're all in the middle of?
Great question. So there's at least a few I can think of. So number one, and I'm going to be brutally honest here, our lead in what used to be 2G, 3G, 4G is shrinking. When I say our, I mean the United States. And we all know that. And we also know what the implications are if we were to in any way lose it. I think the fact is that entities like the NSC, entities that are working so hard to make sure our leadership position is not just maintained, but we gain a substantial footprint in ensuring that others do not infringe on that. I'm truly grateful to the NSC and to the federal government for making that possible. To that effect, there's many aspects that we have to work on to make sure we keep and not just maintain, but grow our lead. And be the leader, not just for 5G, but what we call as 5.5G and 6G. So remember, this is a continuing process, right? Over the next decade, 5G is rolling out now, 5.5G is coming, and then 6G is going to be huge. So we need to make those investments in 5.5G and then ultimately 6G now, so we have the leadership position by 2030 and continue to have the leadership position all the way through. So what matters? I think the interference and interference mitigation, interference management, intelligence are perhaps some of the biggest items that we need to continue building. We need to make this so ubiquitous and make sure that we are the leaders in handling all the machine learning and AI aspects of it, all the data gathering aspects of it, which is again a big, when it especially comes to data, making sure that we control it is very important. And then I think going beyond that, there's going to be opportunities in what's called massive IoT or industrial 4.0, industry 4.0, and many of the other domains in which we are seeing innovation happen today. It would behoove us, it would be very important for us to make sure we are the leaders in each one of those sectors, given the number of applications in Industry 4.0 that are happening today, whether they be advanced manufacturing, industrial automation, I already mentioned IoT, smart cities, smart rural communities. These have not just long-term implications in terms of security and privacy for us, but they have implications for the communities that they're placed in, because a smart community can have a much better overall business and long-term implications for that community. And so the investments being made today in these aspects make a huge difference for us as being a leader in 5G and for the community itself where the investment is being made.
Okay, well, that's a great vision. And I look forward to continuing to work with you and other members of the consortium to try to make that happen. Thanks so much for being with me today, Sriram. Really appreciated the conversation. If anybody out there, thanks for watching, wants to get in touch with either me or with Sriram, please reach out. Thanks again. It's great to have you.
Thank you very much for having me. This was a real pleasure. And I would love to talk to people in the community. I think this is almost a mission that we as a country and as a community continue to innovate together. And to the extent we can work together, I would love to hear from you.
Terrific. Thanks again.